we get these recorded and maybe helps for future reference. Last time somebody mentioned that it was a little tricky to see the slides, that it doesn't fit everything on this into the screen. Just let me know if there is something that we can do to improve the experience. And I ask again for feedback, but few people reply and saying that actually they like the changes. I think that that means that we need to have a break in the middle. That's actually, I think it's a great idea. And I would point out that we are already quite close to the finish line, right? Like these things happen so fast. So we did some of the stuff, like not absolutely everything, because so not everyone had access to the materials. You know, so it's a little bit tricky when you're planning to have materials, need to adapt. We now have a new project that's a bit open-ended. I will talk about this a little bit later, but in general, what I was thinking is, well, you can continue to expand on what we already know. Maybe in some case you want to actually 3D print something. I think that would be really a highlight of the class if it's the first time you're 3D printing. It's a very interesting experience. But in general, we will have in the last class where we are also going to allocate some time to share this project, right? And then that goes to your portfolio. So we're thinking also that part of it is to do research about this, to use some of the tools that we use, that we look. Maybe it's an empathy map. Maybe today we're going to see a couple of other tools, but something, okay, this is a tool that I use. This is something I did in the research. This is something from my design. And then also the thing you build to produce a technical drawing. I think that this, for the ones that went to engineering school, is like, oh, again, it doesn't have to be super complicated. You can do a hand drawing, but you need to have, like, let's say, a front view, a lateral view, so that you are taking all things into consideration. If you are 3D modeling, you just look from the top, you screenshot, you move from the side, you screenshot. If you're using something like Fusion 360, it has an automatic thing. You press a button and a super polished drawing comes out. But I thought that we could review that a little bit. And today I received a newsletter, and it was like, oh, look, this is exactly today. I received a newsletter from Hackaday. I will share a couple of slides. But look at the devices they are showing. Half keyboard, half mouse. So really like a twist on the idea of mouse and keyboard. Even on the USB protocol, they have different IDs. One is for this, ta, ta, ta. The other one is for that, slide, slide, slide. Well, maybe somebody can enhance their productivity with this. Productivity itself, yeah, sure. I mean, maybe we can fill in Excel sheets full of numbers very fast. But why? Yeah, what for? So in the newsletter, there's this series of devices. What about a CISO, right? What about a CISO to control a video game? So some things can be rethought. Also, this very, very clear distinction that we used to have. There are inputs, there are outputs. It has been already quite strange in the sense of like iPads have a very nice touch screen and you navigate, so the output is changing in a digital way. This was not something we were able to do before, but I mean, I think that most of you have no pixels and you have a touch capacitive thing, so maybe it's something that you can touch. and when you touch, the colors change. I think that some of the projects were already going that direction. I remember, I think that Danny was working with something circular. When you put your hand, it changes color. The example that is on the screen is a little bit different, right? Because it's a screen, but the one that has a light is also kind of like a signal of feedback. So humans and computers interacting, but in different ways, right? So joystick, yeah, we already have seen that. But maybe you can like 3D print and add some other buttons. Huge cranking, different kind of keyboards, but also with wood. So I thought that this was interesting, kind of like to put in a context, this thing that we're doing. I propose to hack the mute button just because, right? That day I was upset by the Zoom interface, and the panel moves around on my screen and I don't find it. And I propose to do that. Maybe it's something different. The way that I learned about this is that there is a contest that is called odd inputs and peculiar peripherals. So I think that something that would be super, super fun is that actually your final project becomes a submission for this contest. I didn't include the link, sorry. All inputs hackaday. Yeah, so we'll see that there are many others, right? Some of them I cannot even imagine what are they doing. Yeah, this, I will include a link in the image. So, and then to wrap up on the sense of thinking about these projects, sorry, I made a mistake. These projects live in a context. I had one student that he did well. I wouldn't say that his project was the best of all interactive media, but he graduated just last month, and this is the project that he built. What he has on that headband is an Arduino Nano 33 IoT. I'll play the video, it's very short. So in this video, he doesn't show too much, but some of the examples that he worked out are also thinking about people with different abilities. This is something that is very dear to my research area. And he proposes to that this wearable can be actually used to move maybe with other limbs, right? So maybe you can use your feet to control the computer. And I mentioned that, and now I will move a little bit to the idea of design and a little bit how do we conceptually develop from having an idea to actually come up with that shape. So there is a link here to a full article. Oh, no, sorry, this is a link to a water bottle, right? It's just a water bottle, it explains, but then it explains how it works, like the design it had. But in the following slide, there is what happened here? Oops. Maybe it's loading. In the following page, there is a full description about how was the design of the bottle. Some reason it's not really working. Let's see. What about? That's strange. It was working a minute ago. So I don't know if you know the firm RKS or you have seen some of their designs, but they are we call them iconic, right? Instead of calling a water bottle, it's a personal hydration with style. Maybe a little bit what's happening is that my Wi-Fi is not working well. Am I still there? Can you hear me?
Yes, but the
Oh.
whole screen is like really bad. We cannot tell the character on your screen.
Oh, really? Okay, I'll stop. I maybe what I can do. This was only to share this website. The design is very beautiful. I stopped sharing the screen for a second. Thank you for giving me feedback. Otherwise, I'm left there like not knowing what is going on. So I don't know if you were able to open the link. And my computer is not working for some reason. But anyways, it's a very beautiful bottle, and there is extremely long explanation. I don't think that all of you are going to be totally in to read the whole explanation, but the after the success of having the water bottle design and being so popular, they started thinking about a coffee mug, a coffee mug that is a travel coffee mug. So they have this set of tools that I think that they are eye-opening. What is the process for us to thinking about a new thing? So it's like, it's not how you feel about the design, it's how the design makes you feel about yourself. Right? So really going deep into the psychology. And maybe I will skip some aspects of this that are like much more like business related, but this is an excellent read, right? This is, I think, one of the articles that's like, okay, super, super interesting. And here it mentions this core water bottle and the way to operate, the way to think about this is like, let's go and gather information. Maybe I will download it and open it in my computer. So let's go and gather information from what is in the market. These are coffee mugs, right? They have different. Then same with this, right? Like think, okay, well, there's these things we want to put in there, including like health. It's not just design and innovation itself. And then there's this map that this is for me. Oh, okay. Okay. I think that I'm back. I'm not even sure. I'll try again to share. I can try to continue. Let's see if that ends up well. But please give me some signal, either if you lose me or on the contrary, if you are okay, like let me know. So this map, it's a tool to really go and analyze the psychology of the design. How do we consider this, whatever thing we have, yeah, it's better or worse, in which sense? Okay, so there are at least little drawings. I'm much more a visual person, so you know, it's the Mona Lisa compared with the paperclip, so you cannot get it wrong how useful it is. Right? And then there is a, what is it, a bulldozer against a Camaro. So okay, basic, artistic, enriched, versatile. And then it's a matter of getting pictures and putting them in there, right? Saying, okay, here, here, here. And this is about the product itself. What is out there? What other things already exist? And then there's another aspect of who is our customer? Who is the user? Who are you designing for? And not knowing who are you designing for, you end up designing for nobody. Like it's just like you put things maybe for yourself. So I also went through a similar study when I developed this educational robot. So that's why I'm more familiar. But the idea that instead of talking about my users, the people that use this, actually you put them a name. Even if that is like just a pseudonym, it's just a nickname. It's maybe Sarah has another name, but you start saying, okay, this is Sarah. This is the person. Oh, she lives in this area. She has this income. These are the things that she likes. These are the habits that she goes through. So this is a different approach to the empathy map. We look at the empathy map and we started thinking, okay, what questions can we make in order to extract information? And then you populate that drawing. This one works with a different logic because you need to populate the different areas and say maybe some keywords of how your users react. Fun, loving, passionate, intelligent, unique, entertaining, right? Then you need to find some way that you get there. So one of the ways to get to that place is to have like this kind of attractors templates. So you end up doing drawings, but you make drawings thinking about where is your product going, right? If there are already 25 covering the very, very cheap water bottles, maybe you don't want a cheap water bottle. So here they identify some areas, right? They identify one on the left, one on the right. And then they go and they say, okay, Sarah can fit in here. And then they will go, I forgot the name of the other one, but Justin can fit in there. And this is how they ended up with a water bottle, as mundane a water bottle can be, but also it has a tone of color that according to which is the color you choose, how much money you donate. This is something that also iPhone did. My wife's iPhone is red because some part of the money of the iPhone went to a charity. And I think that I leave it there, but I think this is a great read that explains really how the user will actually get to know your product and how will they feel about it. It even describes this other alternative design tool that is also called the hero's journey, thinking about, okay, they will get to know the product at some point, but how does that evolve in them really using and spreading the voice, telling others. So I highly suggest this as a reading. And I talk about water bottles. I don't think that is a absolutely amazing example, because water bottles sound a little boring. There is an analog example with guitars. So if you're more into music, the explanation about the tools of design is a little bit less, not so deep, but it's the same design studio that they go and they go do a in-depth consultation about Gibson guitars, and they get just on the drawing board, right? Or just on the whiteboard, you have to start thinking about where are the current models. They make a comparison with whatever cars and things like that. These are the things that already exist. And they somehow end up saying, oh, there's this huge gap, there's this hole, nobody did this before. So what if we start developing for that? So they identify personas, and they end up having a series of sketches, all pivoting, all going around where they want it to go, right? Kind of like you don't get it right, but you have enough information on the surroundings. And once that you get there, you start developing further. So they did develop this series of guitars. This is one of them. They had a patent there, and they even share the revenue streams of how many $1 million they generated with this business case. So I think that is it's also a nice way for us to realize it's not just the I always, I study engineering. I have this maybe pre-concept about designers, and they have to be French or Italian, and they have to come with a pen and say, no, I want it on very thin. No, we want that. It's just because it's like the inspiration of the designer. But there are tools, there are things, there are methods for us to research. So these are all, let's say, looking outside. And then once that we have something, once that we find a way for us to engage, okay, there's this little thing, there's a sketch. What do we do with that? Well, one of the ways is to use a method that is called the Wizard of Oz. So you didn't develop it yet. Maybe you have a drawing, maybe you have a little cardboard prototype, as we said at the beginning. So let's watch a minute of this.
Technology, where we know that there's a lot more consideration sometimes that needs to
be explained as well,
particularly if teams aren't 100% familiar with what to look out for. And so before you again start digging really deep into coding and all of those, or manufacturing, Wizard of Oz can really save you a lot. Now, it takes a lot of planning and a lot of detail to run, but it can be worth it, particularly if you're going to run it multiple times. That setup time and the scripting time may be worth it. So I have two examples of times that I've run this that actually aren't related to accessibility user research.
So this lady, actually, she does this for accessibility, thinking about how to make things more inclusive. And she goes on to examples of maybe the way that now you call to a call center and a machine answers you. So before deploying that, before programming the whole thing, and like whatever artificial intelligence, they sit someone Instead, someone like trained with a list of questions and answers on an Excel sheet, and the person talks, but he talks like a machine. So they do that as a Wizard of Oz. The Wizard of Oz, I hope that you recall, right? It's this book and the movie where they go trying to find the Wizard of Oz. And we'll go on, where is this marvelous kingdom? It has magic. But actually, there's a little guy, and he pulls from some strings, he presses some buttons, he shouts, and whatever, and it's just an illusion. So it's okay to lie. In Silicon Valley, what they say is fake it till you make it. So if we are going to really get feedback from our users, we need to show them something quite realistic. So I share that also, thinking that it would be helpful. The last thing that I will share as like with content before we take a little break and we move to the 3D design and design for manufacturing is that I was planning to record a couple of examples, a couple of codes for you to implement. And then I was thinking which ones, because maybe somebody wants to use Wi-Fi, maybe somebody wants to work with Bluetooth. So I included these 2 links that are, I think, unbeatable, like they're like very, very useful. So here in the assignments, in the list of things to do, there is a series of labs, and in the labs, it gives you all the information. And these ones, the ones here, HID, this is what we have been doing, mouse and keyboard, right? Essentially, the things that we have been doing were Arduino. But also the device you have has this Bluetooth low energy. So you could connect P5 with BLE in order to get it in sync, reading the data from your input. Maybe you shake it and something happens, and without a cable, right, with BLE. But also the device itself, the Arduino, can become like a hotspot, right, an access point. It can be a web server. It can access other remote addresses and maybe post like messages to a webhook, like the if this then that, right? So when you shake it, it will send an email. And so all these things, I don't know if you had the opportunity to explore them. I chatted with some of you and you were like, oh, I really would like to connect it more, other things. Well, we cannot cover everything. It's not in our class. But I think that like having the resources here, like device to device also, if you have 2 of them, but device to network, these are the very, very interesting things. And I was saying the last thing before going to a break. So in my case, I have the Arduino Uno, and one of the things that is kind of like easy for me to imagine is that once I selected it and I have the port, I have to make sure that I have this Wi-Fi Nina library. I already installed it, but I will type it in here. The instructions are in the website that I refer as our source, right? Like the one from IDP with connected devices. Wi-Fi, and then it has a name, Nina. Yeah, this one, right? So I have it installed. If you run into serious trouble, it tells you something that your firmware needs to update it. I can help you with that. But in general, the things not that complicated. Once you have the library Wi-Fi Nina, you can play around with it quite a bit. And here you have Wi-Fi Nina. And it has very simple things, right? One of them is a web server. So in the same way that we used to make pages on P5 and you can upload them to GitHub and access GitHub pages, the Arduino Nano can have code and you access it to look at it. So if you choose to do something like this, that is simple Wi-Fi server, here you will need to have something like here, right? Oh, sorry. You can put them here, so you know, like you don't get to see my password. I know that I care, but because this system, so now nobody can see the password because it's a secret SSID and goes to the file. And in the setup, if you look at it, it has a lot of code, but it doesn't do too much. Serial begin, pin mode, output, like very, very simple things. And then it has these other things. Mostly checking, can I start? And then at some point here, it says, go, Wi-Fi begin. So you don't even need to do anything. All these things are already in there and ready for you. Now, inside of a loop, the code is a little long, right? A little long. I wouldn't say this super long, but if you start looking at these kind of things, every time you go through the loop, it checks, did anybody enter my website? And if so, it tries to go and see, did you ask me anything? If you ask me something, I will answer. If you ask which page, I will answer with this, that is the content of there is a page for me to look at. And you will be able to also see it here with this kind of instruction, this HTML code that says, click here. But of course, you are clicking maybe on your mobile phone, right? To turn on an LED or off an LED. So one of the things that you can do is once you do that, is that the click here, you see that it has this href, like this hyperlink. So a capital H will do this, a capital L will do that. So without thinking too much about it, right? But like you have this one on your, I don't know, on your fridge, and you have a light there. I don't know why you want a light on the fridge, but then with your mobile phone, you can access it, and when you press, it will command it. So this is, I think, that like very, very down to earth, and I think that this is interesting for us to have this kind of connectivity. There's also another example, very simple, with Bluetooth Low Energy. And let me see. Maybe I can add one more. I think that this is not, yeah, it's not in the links I put there. I'll put it as well. If this, then that, Arduino, well, Arduino. So let me change the color a little bit. So it's something like this, like the one that I mentioned. If this, then that. The methodology is not very different. The thing itself is going to turn on, logging into the Wi-Fi to your name and password. Here I explain how to do it with the online editor. I don't like that at all. But when you get to the actual code, he explains step by step, right? But like the code is all together somewhere here. So when it gets to the actual code here, you will see that every time there is an event, maybe there's a button, right? There is a signal. In this case, it's the NS coming from the serial port. It will try from the Arduino to go and fetch from a webhook from a website. And what it means is that when it does that, that is outside in the internet, somewhere in the servers of this, then that, you trigger something. This tutorial takes you to send an email. So when you touch Arduino, sends an email. But of course, I work in a little bit, well, different industries. But let's say, for example, I did here in Taipei last year, well, 2 years ago, I did a physical switch, right? So you need to move it. There was an Arduino Nano 33IoT in the center. When you moved it, NeoPixels turn on, and on a Google Sheet, it will add one more. And on a website, a public website of the Taipei hackerspace, it will change the output. So you could see how many people were opening and closing this physical switch. So that's all what I have to share. I'm thinking, okay, these are all, like, I think, terrific tools. We didn't explore them too much. They were kind of things to do. So far, people have been trying to interact with P5 using the mouse and the keyboard. I think that it's the right way to do it. You have a cable there, it's already working. But if you don't want to capture completely your mouse and keyboard, you can also do it with serial communication. There are tons of examples here, right? Well, so many. But I think that, for example, you can start with something like this that doesn't have to build external circuitry, and it just uses the gyroscope, and it will take you to use this through the USB serial cable. And what you catch here, the variables from the IMU, will be sent through the serial cable. And then on P5, you capture these ones, right? You get them from the IMU, you send it through a serial, and of course you need something like this, right? Like you polish a little bit the code. But then on P5, you actually get to here somewhere. Well, in this case, even make a little Arduino Uno in 3D. And when you move the physical model, the one on the screen also moves. But of course, this is going one way. It could go both ways, or it could send more data or faster. There's a lot of explanations here. So I leave it there, thinking that this is, I think, good stuff for the ones that are trying to connect more things, want to explore more with physical computing. It's not my requirement. Kind of like, I'm more interested in that we get to 3D print or build something. And it's a transition for us to go on a break. I thought that we can watch together something. The link is in the, let me see, how do I will try to catch the link from the video and put it on the here in the chat, thinking that it might be nice for people to watch it with better frame rate than if I played. But I will say that this is a great video. I'm going to play it. Feel free to mute me and watch it by yourself. And the reason I want to play this, I was thinking, what do we do next class? Well, I think that one thing that I can share is a little bit of newer design trends. And among those, the project I'm working with Microsoft has been opening my eyes quite a bit. And this video that I'm inviting you to watch with me, it's about design, but inclusive design. So really thinking, who do we design for? In that business case that I shared a little earlier of RKS, the Gibson guitars or water bottle, they're thinking about making money. Additionally, by the way, if it's healthy, better. But really, we are not thinking too much about the resources we're using. We're not thinking too much about who are we designing for. And probably whoever has money, right? Like it has, bottom line, that's part of bottom line. That's the main driver of that article, right? It's in the Harvard Business Review. So I understand the motivation, but I think that it's also nice for us to stop for a minute and think a little bit about, hey, who are we designing for? So there's a very nice scene in this video about a doorbell, and I thought that it was very well connected with our thing. Feel free to send me any questions or write anything, but I will play the video and then we take a break. We meet at 2:30. Does that make sense? 2:30? All right. I'm not sure if you guys are back. It's a little bit difficult to read the situation. I was taking a break, right? Like I stopped for a soda, and I was thinking, are any of these things useful? You know, like it happens to me many times. I go to a lecture of something, or somebody shares a resource, and I say, I will never use it in my life. It's kind of like, very interesting. I will never use it. So I drop out there the thing, you know, the connected devices, the ITP physical computing. That are the example of if this then that. Did anybody ever try something like this? Is it like totally brand new? Or maybe something you don't want to try because it's kind of like, if I have a phone that has all the Wi-Fi things, why do we want an Arduino? I see the benefit because you can have sensors and motors. Did you ever try something like that? Or do you think that is interesting for any of the projects, who knows, in the future? Or so I have Joseph as the first target because he has a camera on, so kind of like easier. But can you imagine?
Yeah, I think I did some projects with Arduino before because of the last year class. The class name is Connection Lab or something like that.
Yeah, the interface lab. Yeah.
Interface lab.
Yeah. How did you connect P5 with Arduino? How was them?
I was trying to make Arduino synthesizer or Arduino, Arduino instrument. So I try to use Arduino to control the P5 sound.
Yeah. Did you do it over the cable or over Wi-Fi?
Over the cable. Yeah.
Okay. Have you? I don't know. Yeah, I'm not sure if you know this, but for something like that, like the synthesizer, have you heard the conference New Interfaces for Musical Expression, NYU?
No. Yeah.
Yeah, so the NYU conference, it's like this, right? New Interfaces for Music Expression, and it happens that it has they have an award, and the award is called the Pamela Z.
Oh yeah.
So Pamela Z, she's fantastic. Let me try to get. Yeah, something like this. Because she has a synthesizer, but she works with her voice. So you will see. Like, this is not a video we're thinking about, but.
Yeah, Rudy, I think the internet is a little bit stuck. I
Oh yeah,
so
the image is not working.
yeah.
Yeah, yeah, I don't know what to say. Sorry. What can I say? Sorry. Yeah, she has some different devices, and some are wearable, and some are in a little box next to her performance. So you see there's a little box there, obviously with a ultrasound sensor or something, right? You can hear. Yeah, different synthesizer, but somehow connecting. I think that she probably has some Raspberry Pi there. It's not an Arduino because she's catching a lot of information. And yes, yeah. So please feel free to give me feedback. I'm going to move towards an area that I find interesting. That is, you have this idea, and then it's okay. I'll make it, right? I'll give it to a factory and somebody will make it for me. So the whole conception, the whole idea is like the shoemakers, like the Industrial Revolution, the first Industrial Revolution. There was a shoemaker, and then a factory put all the shoemakers all together, and they were giving them whatever, leather or something. They were doing kind of the same work, but in a line. Then there was other industrial revolution where actually machines were incorporated. And now this new revolution is actually like going so fast that we cannot even understand what's happening, right? It's like, yeah, because the digital and the thing, and then we keep on the QR code, right? Like it's really, really difficult to keep track of it. So maybe a little bit of perspective is to think back in the day, the first Mac, the first Apple computers, not Mac, but the first Apple computers needed funding. So I think that they sold 25, I forgot the number, but they sold 50. And there was a lot of money. And with that, they financed the whole company and they studied a lot of things. Well, truth is that that's okay if you are doing something on the very small scale. There is a link there. If you're interested, you can read a little bit more about this. This article is very dear to me because it came out after I finished my Kickstarter campaign with the first robot I sold. And yeah, we got the $130,000, but definitely not enough. Part of the reason is that you need to stock, you need a whole team, the logistics, and then what is the amount that you're producing? Are you making 10, 50? Well, they need to be very, very expensive 50 things so that when 100,000 K, you actually move forward. If you make millions of units of something in the industry, is when the economy of scales actually starts working. And this works against another thing, that this is an anecdote that somebody was in the team of logistics for this fidget cube. I don't know if you have seen this, right? It's a little plasticky thing, and then you can manipulate it and whatever, right? It doesn't have anything inside. It's just like a cube that is nice for you to maybe release stress. Oh, somebody make a tattoo. Oh wow. Okay, so they had the Kickstarter campaign. They got a lot of money. I forgot exactly how much, but a lot of money. By the time that they were finishing the campaign, the project, they got $6 million, right? So it's, when I was saying $100,000 is not enough for some things, right? But these ones, they got $6 million, but they started placing the order in China. They started asking supply. By the time that they finished the project, they finished the campaign, they started talking with suppliers. By the time they were about to start delivering, the already hired company that will start to, a fake fidget cube already came into the market. So how did that happen? This happened also with the iPad back in the day. The whole idea that we will do marketing and then manufacturing and something or whatever, and then finally we'll act on the logistics and go and build the thing, it was just too slow. So it's really moving. They re-engineer the iPad or the fidget cube like nothing, just by looking at it very, very quickly. And the one that had the idea, well, it's very difficult to take it from there, right? To actually build a business like that. So what is being discussed now, a little bit like what is at play here, is that there is this idea that there is a black, you put in there maybe some designs, some ideas, some information, and things come out, right? Whatever, the products, right? Somebody will make it for you. And it's very far from the reality. It's like, yeah, sure, there is a process, but it's not linear. So there is an article, I don't want to bomb you with a lot of information, but I think it's good that we have some references. The one that is interested, take a look. The reality is much harder than you thought. That's the you know, the moral of this. It's like you think about building something, but right, like you have the electronic, the Arduino component. You think of the case, but then when you want to put it, well, maybe the dimensions need to be rechecked, or maybe the place that the button goes, maybe the material is not strong enough. Maybe there's something that you didn't consider that your users will. In my case, when I started shipping products, one of the things happens is that I was putting them in a very nice box and I send them by airplane, but the storage in the airplane gets very cold, very, very cold. I don't know exactly how cold, but as cold as making the plastic fragile. So it kind of, I was freezing my plastic. I was using cheap plastic and it was getting broken. And it's not fun when it happens to you, right? So I would say that this will lead us to one idea of, hey, when we design something, we need to actually move fast and be also proactive in what methods we use. And this idea goes together. There's also a link here if you're interested in more explanation. But the earlier we test, the earlier we design with changes in mind, the better it is. Because at the moment that it's paper, you throw away the paper and you make another piece of paper. Because when you have the Arduino with a cable here like that, or 3D printing, it's still okay. But the moment that you get to produce this, to change it, it's very, very costly, and maybe it kills the whole project. That's part of what happens. So I will not talk in like great detail, but there are these techniques that I work in the factory for quite a bit of time. And these are things that, like the surroundings of electronics that have an Arduino, they have these, right? So I'll just play a short video. There is an explanation. I don't think an explanation is important for us.
And I'm here to demonstrate a little bit.
But essentially, there's raw material in one of those baskets. The raw material looks like little coffee beans, let's say, right? So these plastic pellets, they go and they melt, and the machine has something that's quite expensive, that is the mold. Right? So there's this cavity where the plastic melted will be injected, and that thing is going to stay there for some period of time till the plastic gets in, and then we will open and we will get the finished thing. So you see there, this one is a little bit sophisticated. It has like a robot arm taking the piece of plastic, but everything, you start looking around, there's a lot of stuff of plastic. Well, they were injected with a similar process. And it's not very fast, right? Each one of them closes, it puts the plastic, needs to cool down a little bit, opens, and then ejects. So this means that it's a cycling time, and it's not very cheap. And of course, the mold is very expensive. Maybe it costs 100,000 RMB, one cavity. So that's part of the thing that, okay, when you make something plastic, you need to make many units. And then the processes, I put some here thinking, well, many of the other things we have around, I have this beautiful designer pen. They have been CNC, right? You realize that this is not plastic, it's metal, and you start looking at it and say, oh, okay. They put this into certain machine. The machine was either spinning the thing or spinning the tool, right? So there are different processes. I chose two. I think you are also quite familiar. Maybe there's something of the different dimensions, so then it needs to be adapted. This is a process. Maybe it's not that expensive. The same for stamping. So when I made my robot sets, some of the things we made them in plastic, but others we made them on metal. And the metal comes as a sheet. This one is moving very fast. But the machine goes, and by impact, it cuts. It's like, but instead of a scissor, it goes like taking pieces of material. It can modify the shape as well. So this process, it's well, the machines are very noisy, right? You can see that people are using earplugs, and also a little bit dangerous in the sense of the personnel there. Many have like a missing finger, and it's a little dirty, so it's not very good for health. But when you start looking things around, again back to my pen, this clip, I'm 100% sure this was stamped, right? So we start looking at things around and say, oh, okay, they injected, the machine, the stamp. Oh no, okay, there's a combination of these because you get the screw that was produced with a die casting. So there are certain processes that have been involved. And a little bit what happens with all this is that there's a combination that you need to study. How does it work for you? So I include a couple of drawings there, trying to put an idea about sometimes one of the things that's going to be like key for us is how many do we make? Because after maybe 1,000 units, I was saying 100,000 RMB, maybe it's a little bit less, $10,000. That's a cost of opening a mold for injection. An injection, actually, the unit cost is not expensive. But those molds of like stamping or whatever, maybe it's like 1,000 or something like that, not so much. But actually, the unit cost is more expensive, metal made. So you can see where it starts making sense to use one method or the other. One of the best things I can advise is like for the level of this class, right? Device design, well, it's like a panorama of everything. We talk about this idea of having a double diagram design, a double diamond design cycle, and this diagram has like a very linear interpretation, right? It goes to from A to B, but maybe we can start thinking about it. Okay, is getting the right idea very, very important at an early stage. And then once that you have that thing, you are very sure you did the prototype with Arduino and it does the function that you want. It looks like you like it. Actually, maybe getting the idea right? So what is the process that can help you? And here is where you start thinking, do I 3D print? Do I laser cut? Do I do it with cardboard? Do I hire a studio to make a thing because I will make many units? How much does it cost? So some of the things, as we are in China, it's so beneficial here that we can go and talk with the factory. So that's part of what I'm going to go. I'm working towards that, right? It's super important for us to be able to understand what options we have. And I left one more diagram of this double diamond idea, trying to also think maybe this whole thing of I will go from I have an idea to I have a solution. It's not like that. It's like that doesn't work like that. So you will stay lost a little bit in this loop for a while, right? Till you decide, okay, that is, maybe you make a little setup with a Wizard of Oz technique. You just fake it. It looks like the real thing. You have a design specification. You know what you want. But now you need to really make it. And here is not linear either. You will stay iterating and iterating until you actually get it right. So that's my best advice of like trusting that there is a process in place. And perhaps the whole idea of design for manufacturing, it's all about reducing the cost, making it cheap, right? Like that's what it was understood in the industry by design for manufacturing, but that has been also challenged. And I think that many of you doing this low-res MA, you have all these ideas. How do you put them together? Why do you want to do design for manufacturing? Well, I think that there's a very compelling reason. And it's not only to make it cheap, but then once you start understanding, oh, okay, there are processes, maybe there's tools, all different things have different codes. I can 3D print or I can laser cut. You can read a book like that, the one this diagram I picked up is, like the drawing I show in slide whatever 240. It comes from comparing how much does it cost to build this auto part in this or in this material, right? So there's a moment that actually it clearly makes more sense one material than the other, and there's going to be another side that is not about the cost. So I'm trying to go there and trying to think a little bit how to explain it. But for you as a designer to be able to get what you want, you really need to go and talk the dialogue, to talk in the vocabulary, in the language of the people in the industry. So one of the things that happened to me was that I wanted to build the robot, right? So I made a little list, and in my list, I thought about which things I have. It's called a bill of materials. Right? So I have so many capacitors, I have so many diodes. But then the factory came back with something like this. And it's like, oh, okay. For each one of these little things, they want me to buy whatever, right? 16,000, 4,000, right? Each one of them. So then you start realizing, okay, these components come in a rail. The rail has so many units. So it's so like a game about understanding what you have available. And one of the things that I did that I thought that was the best experience was to actually go to the markets. So these pictures were taken by me. The one on up there is the Canton Fair. Right? I forgot how to say it in Chinese, but I think that you know what I'm talking about. And the one on the bottom is the Yiwu market. I was in the toy market, so I went to Yiwu to see and to contact suppliers. By then, I didn't even know, in China, you give a name card with 2 hands, right? Like these kind of things. What do you really say? But mostly what is going to happen in that dialogue is you need to be very, very clear when communicating with a supplier about how many units do you want to make? Do you want to prototype? Prototype how many? 3, 5, 25? You plan to make 3 and then 30 and then 3,000. So these kind of things are going to be very important for them. And I'll skip a little bit so that it's not so heavy. But I would say that when I produced this robot set, one of the things that was happening is that I was getting prices that I was like, oh, okay, each one costs like 2 cents. I was very, very happy, right? And a little bit what happens is that when you start thinking about this that I was showing before, well, it piles up, right? Like you need to produce many components and you need to start thinking about which ones do you want to place a big order, which one has a fixed cost, and which ones has a huge, it's called non-recurrent engineering cost, like to start the process. And I think that maybe along with that, the other thing that is very important is to also challenge. I was challenging this idea that you need to do design for manufacturing because of the cost. The other thing to challenge also is there's this idea that you will have like this linear, waterfall model, or sometimes it's called the Gantt diagram. The requirements trigger the design. The design will give you a certain implementation. You will check that, verification, and then you just keep that on. And the timeline, I mean, it starts like saying, oh, okay, how do I actually get this done? And I think that one of the ways to rethink this is that maybe for a modern agile way of keeping a project, what you can do is instead of thinking about that old diagram that I think that you're familiar with, right? Like the chain of tasks, one after the other, is to start thinking about having milestones. So for this more modern society we live in, where you actually go and click, and you get a new design, or you get somebody to design for you. This is actually a very useful tool for project management. Then the SMART comes from abbreviation of having specific, measurable, achievable, realistic, and timely deliverable of the milestones. So you find some checkpoints, right? So you check how are these, what is the process of this project. I'm skipping some slides so that it's not so heavy. I think that otherwise it's going to be maybe too much. But whoever is interested, I included there some software to manipulate more the keyboard and key combinations. And I was thinking also a little bit like this idea of what I was talking about of the old mindset, the old model, and the new model has to do with this mindset of big corporation, and they want to make money, and there is a requirement that need to fit in because of a marketing insights, compared to a growth mindset of, hey, let's try to do something new, let's try to invent, let's try to think how do we use our capacity of thinking outside of the box. And this has been seen in software extensively, right? Like a company that works like the banks are one case, right? But like the company that works with this very, very linear way of developing software, they go very slow and they make a lot of mistakes, and it's actually very painful to see them going, like, getting stuck. But there are other models. This one is one of them, the agile, that actually they're like thinking constantly, hey, how do we innovate? What are we doing? Are we doing things the way we want? And part of it is to be informed all the time, to be aware of new solutions. So the idea of a black box and a very linear process, I feel, yeah, it's a little too late for that. We are already in year 2022. So I think that this idea of agile has been happening in the industry of hardware. To make a device today, you need to be aware that things move very fast. And all that's up to this more modern idea of design for manufacturing.